Name a predator that kills prey bigger than itself. Lion, wolf, killer whale, African wild dog, wolverine. Look at that list again, because there is a pattern hiding in it. Every animal on it carries its weapon inside its own body. Teeth, claws, bite, force, or just mass. Thrown at something the way you would throw a truck. A lion cub has a lot to learn about how to use those teeth, and it spends years learning it. But nobody has to hand the cub the teeth. They arrive with the animal. They show up on schedule, and they cannot be lost or forgotten or left behind at the last camp. Then there is us. Blunt fingernails, flat teeth, slower than almost anything worth eating, pound for pound weaker than a chimpanzee. And somewhere in the record of what the human lineage ate, there is an elephant that weighed 13 metric tons. Here's the part almost nobody gets told. We are the only large predator whose weapon has to be handed over. Every other hunter on that list is born already holding it. Ours has to be made by somebody, given to somebody, and explained to somebody. And every single one of those steps can fail. A group can lose the whole thing in one generation. Nothing about a lion works that way. So the real question is not how ancient humans killed animals larger than themselves. The question is how anybody worked it out in the first place, and how that knowledge stayed alive long enough to matter. Start with the animal. Picture something 4 meters at the shoulder. That is about 13 feet. Taller than a basketball hoop. At the shoulder. Before you get to the head, adult males reached body masses of around 13 metric tons. Park 2 loaded dump trucks side by side and give them tusks. Straight tusked elephants were 3 times the size of a modern Asian elephant, twice an African one, and bigger than a woolly mammoth. They were the largest land animals that have existed in the last 3 million years, roughly 125,000 years ago. In what is now central Germany, Neanderthals were cutting them apart. We know that because of a coal mine. Between 1985 and 1996, a brown coal quarry near the city of Halle was chewing through ancient lake sediment, and archaeologists were racing the machinery. What they pulled out is still the largest collection of its kind on Earth. The remains of at least 57 straight tusked elephants sitting in fine lake mud, with cut marks on the bones. Now, cut marks alone do not prove a hunt, and this argument has been running for decades. Big animals die near water. A person walking past a carcass with a sharp rock is a scavenger, not a hunter. For a long time, the reasonable position was that early humans showed up late and took what was left, because the animal had already done the hard part by dying. The thing that settles it is not a weapon. It is a list of who died. Any wild population that dies naturally leaves a signature you can read. You get a lot of very young animals, because young animals die at high rates. You get the very old. You get both sexes in rough proportion, because drought and disease and old age are not picky about who they take. Dig up a place where elephants simply died over a few thousand years, and the age and sex profile comes out looking like the population that made it. Neumark Nord does not look like that. The assemblage skews hard. Adult malice. Prime animals. Individuals in good condition. Natural death does not produce that. Scavenging does not produce it either, because a scavenger takes whatever the landscape hands him, and the landscape hands out everything. A skewed profile means somebody was choosing, and the choice runs the opposite direction from what almost everyone expects. They were not picking off the weak and the sick. They were going after the largest individuals of the largest land animal in 3 million years. That sounds like a death wish, right up until you stop thinking about size and start thinking about behavior. Female elephants, then as now, almost certainly lived in groups with calves in the middle and a lot of adult attention pointed outward. Walk toward that, and you are walking towards 6 animals at once, all of whom will make the same decision about you at the same moment. Adult males spent much of their lives alone. One animal, one direction of attention, nobody arriving from the flank because they heard something. The male was heavier. The male was also solvable. That is the first thing anybody hunting large animals has to work out, and it is not obvious. And you do not get there in an afternoon. What matters is not how big the animal is. It is how many other animals are standing with it. Someone had to notice that and be right about it, and still be alive afterward to tell anyone else. Knowing which animal to approach solves nothing on its own. Though, the thing is still standing there, weighing about 180 times what you weigh. The next problem is not the elephant at all. It is the dirt under its feet. The team that worked through the Neumark Nord bones offered a suggestion about how these animals were brought down. And I want to be careful with how I say it, because a suggestion is what it is. The site sits on the shore of an ancient lake. Their proposal is that the soft margins of that lake were used to bog the animals down before anyone came in close. Nobody excavated a trapped elephant. What we have is a lakeshore, a lot of dead elephants, and a physical explanation that fits. Hold it as a reconstruction, not a recording. But sit with the physics for a second, because it is worth understanding why researchers keep landing on it. Mud does not care how much an animal weighs. Mud cares how much weight is pressing down on each patch of foot. 13 tons standing on soft ground is 13 tons distributed across 4 contact points. And every one of those points is trying to sink. Once a foot goes in past the joint, pulling it back out means fighting suction. And fighting suction means shifting the entire load onto the 3 feet that are also sinking. The animal's single greatest advantage gets turned into the thing working against it. Then there is what the same ground does to a person. Almost nothing. Somebody weighing 70 kilos walks across terrain that swallows an elephant. Wherever a confrontation happens, changes what the confrontation is. And that is true, whether or not anyone at Neumark Nord ever deliberately drove an animal anywhere. Water margins keep showing up in this story, which is the part I find hard to write off. Go about 800 kilometers northwest, and 75,000 years earlier, to a German site called Schoningen. Around 1,500 flint artifacts scattered among the butchered remains of more than 50 horses along the shoreline of a lake that is no longer there. The excavators read it as the residue of repeated ambush events. Not one hunt. Many. In the same spot. Over time. I am not going to tell you that proves a technique was passed from one population to another across tens of thousands of years. It does not. 2 groups can find the same advantage independently. The same way 2 people can figure out that a doorway is a good place to wait for somebody. What it does tell you is that the advantage was real and it was findable. Wet ground is soft. Animals come to water on a schedule. Approaches near a shoreline are narrow. Any group that read those 3 facts correctly got something the animal could not take away from them. Now, let me get in front of the picture that is probably already in your head, because it is the single most repeated image in this entire subject, and it does real damage. The cliff. Everybody has seen the painting. A herd of mammoths pouring over a rock face while small figures wave torches behind them. Buffalo jumps are real, and they are documented beautifully. Head smashed in southern Alberta. Has bone beds meters deep, and it is one of the most impressive hunting sites anywhere on the planet. It is also bison in North America, and it is young. That technique belongs to the last several thousand years, and it keeps getting pasted backward onto European elephants 100,000 years ago and further. That is the internet doing it, not the evidence. The evidence points somewhere wetter and a lot less dramatic. Soft margins, narrow ground, places where a big animal loses more than a small one does. And every one of those places has to be learned. Which shoreline goes soft? And in which month? And how far out you can walk before it stops holding you. That knowledge sits in a specific valley. It changes with the season. And it is worthless anywhere else. You get it from somebody who has already walked it. The ground holds the animal. The ground does not kill the animal. Somebody still has to close the gap, and that is where this gets expensive. In 1994, a wooden spear came out of the coal at Schoningen, then another, then more, until the site had produced the most complete set of ancient hunting weapons anybody has ever found. Spruce and pine, about 2 meters long, shaped. So the thickest part sits forward of center. Pick one up, if you can imagine it. The mass comes in almost exactly at the weight of a men's Olympic javelin. That is heavier than it sounds. Hold it out level at arm's length and your shoulder starts talking to you within about 10 seconds. This is not a thing you flick. This is a thing you throw with your entire body. For 30 years, those spears have been carrying a number that is wrong. Look them up and you will find 400,000 years. Stated flatly, all over the place. That figure stood for a decade before it got walked down to about 300,000. Both numbers had the same crack running through them. Nobody was dating the spears. They were dating the dirt above and the dirt below and splitting the difference. Which is a fair thing to do when you have nothing better and a bad thing to lean on for 3 decades. In 2025, a team finally got a date out of the layer itself. The method runs on amino acids, and it is worth 30 seconds because it explains how we know anything here. Proteins in living things are built from one mirror image version of these molecules. After death, they slowly flip into the mirror version. At a rate you can measure. Count how far the flip has gone, and you get elapsed time. The team pulled fossil freshwater snail shells straight out of the sediment, holding the spears, and read them. The answer came back at about 200,000 years. That is 100,000 years younger than the figure still sitting in most articles about the site. And it does more than tidy a timeline. At 400,000 years, these weapons belong to Homo heidelbergensis. At 200,000, they belong to Neanderthals. The most complete hunting weapons in the archaeological record changed hands, which brings up the fight that has been running about them since the day they came out of the ground. Were these thrown, or were they held? The default answer was held. A spear this heavy, moved by a person on foot, got treated as a close-quarters tool. Useful out to maybe 10 meters at the very limit. 10 meters is nothing. 10 meters from an animal that covers 10 meters in about a second is a hospital visit with extra steps. That assumption came out of experiments where ordinary volunteers threw replicas, which turns out to be a serious problem. Hand a 2-meter spruce spear to somebody who has never thrown one. Record how badly they do. And you have learned something about the volunteer. So, Annemiek Milks at University College London ran it a different way. She brought in 6 javelin athletes. That choice matters more than it sounds. These were people who had spent years throwing exactly that mass at exactly that kind of velocity. If anybody walking around today could stand in for a hunter who had been throwing since childhood, it was them. They hit targets out to 20 meters. With enough energy on impact to translate into a kill. double the distance the weapon was supposed to be capable of. At 25 meters, the hit stopped entirely. Whether that comes from the spear, the arc it has to travel, or the simple fact that nobody alive practices aimed spear throwing for a living, the study does not say. 20 meters, by the way, is about 65 feet. Home plate to the pitcher's mound is 60 and a half. So call it a fraction past a pitcher's mound. Add an animal that is not standing there waiting for you. That result got a lot of coverage. And it earned it. But there is another number in that study, and almost nobody quotes it. The hit rate. At about 20 meters, the athletes hit the target roughly 17% of the time. Closer in, around 10 and 15 meters. Roughly 25%. Read that again. These are competitive javelin throwers. They are throwing a weapon matched to the mass they train with, at a target that is standing perfectly still, in daylight, on flat ground. The target is not moving. The target is not watching them. The target is not going to turn around and come back. 3 out of 4 throws miss. Now put a horse in front of them, a horse that will be 40 meters away before the spear lands if it hears the release. Put them in wet grass at dusk, after 2 days of tracking, with bad footing and one attempt before the entire herd is gone. Whatever made a Neanderthal hunter dangerous was not sitting in the wood. There is nothing in the wood. It is a shaped stick with good balance. The gap between a person who can hit a horse at 20 meters and a person who cannot is measured in years of throwing. And years have to come from somebody who already spent them, standing there, correcting you. And even when the throw lands, this is a long way from finished. Around 500,000 years ago, at a South African site called Kathu Pan, somebody was doing something new. Stone points from that site carry fracture patterns typical of impact, and wear near the base consistent with being bound to a shaft. Read together. That is a stone-tipped spear, and it is the oldest claim of its kind by a wide margin. The claim is contested, and I would rather say so now than let you find it out later. Other researchers have argued those fractures could come from the tool-making process itself. The original team defended the method. The argument has not fully closed. So treat this as a strong reading of a real pattern rather than a settled date. Set the date aside anyway, because the better question is why anybody bothered. Everybody assumes the answer is obvious. Stone point goes deeper, sharper, harder. Punches through hide that a sharpened stick would only bruise. It feels so obvious that for a long time nobody checked. Jane Wilkins and colleagues checked. 10 spears, built as close to identical as they could manage. 5 with a quartzite point hafted on. 5 just sharpened wood. Same mess. Within the noise. Fired from a calibrated crossbow, so every shot delivered the same force. The targets were ballistics gelatin, the standard medium for measuring what a penetrating weapon does once it is inside a body. The tipped spears did not go deeper. What they made was a significantly larger inner wound cavity, one that widened toward the far end of the wound track. In ballistics work, that cavity is the number that actually matters. It is what stopping power measures. The advantage of a stone tip was never how far in it got. It was the size of the hole once it was in there. That came with a cost attached. A stone point introduces a failure the wooden spear does not have. It can fracture. It can come loose from the shaft. It needs replacing. And replacing it means having the stone, the binding, and somebody who knows how to put the thing back together. Whoever made that trade decided the wound was worth the maintenance. Now, a note on what the gelatin can and cannot tell us. It is a proxy. It does not have hide, hair, fat, muscle grain, or bone in it. And the researchers who ran the test said as much. What it measures well is the difference between two weapons under identical conditions. What it cannot do is tell you what happened to an elephant. Here is the number that reframes the whole problem. Though, to reach the chest cavity on a large hoofed animal, estimates put the required penetration at somewhere around 20 to 25 centimeters. For something bison-sized, over 50 centimeters. 50 centimeters is a foot and a half from a hand-thrown weapon, through hide and muscle laid over ribs. Scale that up to 13 metric tons, and the arithmetic stops being encouraging. A single thrown spear was unlikely to produce a reliable, immediate kill on an animal that size. It could still be lethal. Large blood vessels, lungs, the neck, the gut, repeated wounds, slow blood loss, or some combination could all end the same way. What archaeology cannot give us is the sequence. Nobody knows how many strikes it took, or in what order, or how long the animal stayed on its feet, which puts us at the hardest moment in the whole business, and the one that never makes it into the illustrations. The spear has landed. The animal is still standing. It is bleeding. It is bogged. It is turning. And it is now looking for the person who threw it. Everything discussed so far has to work at the same time. Right there. The choice of which animal to approach, the read on the ground, the distance, the throw, and now a decision about whether to close in with a second spear or back off and wait. Made in a couple of seconds by people who cannot afford to be wrong twice. That is a coordination problem. And coordination is a thing you rehearse. Somebody has to know where everyone else is standing without being told. Somebody has to know when to move and when to hold. Nobody works that out during the event. So if it was not strength, and not one heroic throw, what actually brought those animals down? Dozens of times. Over thousands of years. For 30 years. The most famous answer to that came from a set of broken bones. In 1995, two researchers published an analysis of Neanderthal injuries out of 17 skeletons. Roughly 30% showed cranial trauma, and the damage clustered high on the body. Head, neck, arms, very little in the legs. They went looking for a modern group with the same signature and found exactly one. Rodeo riders. The conclusion wrote itself, and it went straight into popular culture and never left. Neanderthals fought their prey at arm's length, hanging onto animals that were actively trying to kill them, which is why their skeletons look like the skeletons of men who ride bulls for a living. The story kept moving after that. Almost nobody followed it. In 2012, one of the original authors revisited his own hypothesis in print and said it needed to be heavily qualified, if not simply withdrawn. The samples had been small. The same pattern turned up in early modern humans. And there is a preservation problem underneath the whole thing. Because a person with a shattered leg does not walk back to the cave where skeletons get found. Then a second team ran it again with a much larger comparison set, pulling injury data from 84 different activities. 70 came out statistically different from the Neanderthal pattern. Of the 14 that matched, the researchers noted it was hard to imagine any Neanderthal behavior corresponding to them. The matching list included water tubing, throwing flying discs and boomerangs, and accidents involving golf carts. So, the strongest evidence ever offered for Neanderthals wrestling megafauna, once you widen the comparison, fits a golf cart accident about as well as it fits a mammoth. They still got close sometimes. bogged animals get finished at short range, and short range is short range. What collapsed is the idea that we could read their hunting style off their fractures, which sends the question somewhere else entirely. If the bones of the hunters cannot tell us how this worked, try the arithmetic of the meat. Take one of the Neumark Nord elephants. Not the biggest. A 10-ton animal. Comfortably mid-range for the site. The researchers ran the numbers on what that carcass yields. And the figure they landed on was a minimum of 2,500 adult rations at 4,000 calories each, with a workable balance of protein and fat. From one animal. 2,500 meals. One elephant. Then there is the labor on the other side of it. Skinning the thing. Stripping every usable piece of meat off the bone. Taking the fat-rich foot pads. And drying or smoking all of it before it spoils. Their rough estimate for getting through an adult male was 3 to 5 days, with about 25 people working. Both numbers are describing a group, and that is where this gets interesting. 25 individuals has long been treated as roughly the ceiling for a local Neanderthal band. The butchery estimate needs that entire ceiling working most of a week. And the food yield runs so far past what a group that size can eat before it rots, that you are left with two options and no way around either. Either these people were gathering in numbers substantially larger than anyone assumed, or they had real methods for preserving and storing food at scale. Possibly both. You can read social structure off a pile of bones. That is what makes the site remarkable. And it has nothing to do with how big the elephant was. The thing that actually matters at Neumark Nord is the calendar. This was not one extraordinary week. Hunting elephants at that scale was part of what these people did at that location for more than 2,000 years. Dozens of generations. And it was not just that lake. Reanalysis of elephant remains from two other German sites, Grobern and Taubach, turned up the same butchery signatures, which moved it from a local quirk to something happening across the region. Luck does not run for 2,000 years. None of it is discoverable by one person in one lifetime. Either. Which animal to isolate? Which shoreline goes soft in which season? How far to stand? Where to put a spear when the chest cavity is out of reach? How many hands it takes to process the result before the meat is worthless? That is a body of knowledge. And every generation at that lake either got it from somebody still alive to hand it over, or lost it. So we have arrived at the actual question in the title. And I have to be straight with you about where it stands. Archaeology records outcomes. It does not record teaching. We have the spear. We have cut marks on a femur. We have the mud at the edge of the water and the age profile of 57 elephants. Nobody has ever excavated a lesson. There is no artifact of an adult fixing a child's grip. No fossil of somebody being told to wait. No bone that preserves the moment knowledge moved from one head into another. So researchers went looking sideways for something else in the record that is too hard to invent alone. If a technology takes more steps than a single person could stumble through, then the object itself becomes the evidence that somebody was taught. The best candidate is glue. Birch bark tar is the oldest synthetic substance humans ever made, and Neanderthals used it to bend stone points to wooden shafts. For years, it carried enormous weight in this argument, because the method thought to be behind it was a stepwise process of heating birch bark underground in oxygen-starved conditions. That is not a thing you fall into. It has stages. It has temperature control. And it gives you nothing until the end. Then somebody found a shortcut. A separate team showed that usable birch tar turns up as a fairly ordinary byproduct of just burning birch bark in the open. Burn it beside a hard vertical surface. A stone sitting next to the fire. and tar deposits on that surface where it can be scraped off. Enough of it. In a single work session, for a while that seemed to end the argument. If tar can be made by accident, then finding tar proves nothing about anybody's mind. But the question was never really whether tar existed. It was how a particular lump of it got made. And chemistry can answer that. Because different production methods leave different molecular fingerprints. 2 tar samples from a German site called Königsau were run against tar produced experimentally by several different methods. They did not match the open-air shortcut. They matched the underground. Oxygen-restricted process, which takes multiple controlled steps and a person who already knows all of them. So the evidence for transmitted knowledge is still standing. It just moved. The presence of tar tells you nothing. The way a specific piece of tar was made tells you a great deal. And at least one Neanderthal batch was made the hard way. That is where things sit, not closed. Researchers are still working through which samples were made, how, and the wider argument about Neanderthal culture will be running for a long time. So the honest answer comes in 3 pieces. And they do not carry the same weight. What is measured? Neanderthals hunted the largest land animal of the last 3 million years. Repeatedly. At multiple sites. For more than 2,000 years. Trained throwers hit a stationary target with a replica spear, 17% of the time at 20 meters. A stone-tipped spear opens a wider wound rather than a deeper one. What follows reasonably from that? Nobody assembles this alone. The failure rate on a single throw is high enough, and the cost of a bad decision severe enough, that this had to be knowledge held by a group and handed forward on purpose. What is still open? The mechanism, how it was taught, whether by instruction or by years of watching, and what the failures cost. We have the output and almost none of the process. Go back to that list from the beginning. A lion cub learns plenty about how to use its teeth. It watches. It fails. It gets better. But no lion in history has needed another lion to survive long enough to hand over the teeth. The equipment shows up on its own. And it shows up whether or not anybody is there. What that lake bed in Germany records is 2,000 years of people bringing down the largest animal that has ever walked on land. In a place where nobody was born knowing how to do it. Holding weapons that nobody is born holding. Every generation there had to take all of it from somebody who was still breathing. The real weapon was never the spear. It was somebody sticking around long enough to put it in your hands and show you how to hold it.